All right. All right. Thanks, everyone. Good evening. Well, if you're on the East Coast, good evening. It's now 6:30 New York time. We're live from New York. Thank you for joining. We have an amazing group here working today. If you want to ask questions, please ask questions as many as you can. We have the chat going on. We have a lot of people from our group are monitoring the chat. They're going to be answering the questions, or they're going to be sending the questions to Ray. So just give a little information. Here's some ways that you can reach out to the JavaSIG, here the YouTube channel. The Twitter is the best way to reach out to us. We're very active on Twitter. So our handle is NYJavaSIG. NYJavaSIG is an amazing group of people. We have a bunch of Java champions. So have Frank Greco, Chandra Gantour, Gene Boyarsky, Justin Lee, Victor Grazi, that's very present on the group, Donna Rab, that's very present on the group, and Ray, that's the presenter today. He's an amazing professional and also a Java champion. He's very active on the group. He's a friend of ours. And please follow us on Twitter. More followers we have, more people we want to speak at the NYJavaSIG, and we can bring better content to you. So it's a win-win, all right? So again, please ask questions in the chat. We're going to be monitoring all the time. And I wanted to introduce our speaker today. So Ray Tsang, he is a developer advocate for Google. He's an amazing professional. He speaks at the best conferences of the world all the time. Ray, thank you very much for joining us tonight. It's a pleasure to have you. And I'll hand up to you now. Thank you.
Okay. Yeah, thanks for having me here. It's absolutely wonderful. Yeah, so should I go ahead and share the screen? And let's get started?
All yours.
Perfect. All right, thank you so much. This is great. Let me go ahead and share. Make sure, there we go. We should be live. Awesome. Yeah, and thanks JavaSIG for hosting this session. Like Rodrigo said, an amazing group of people. Really fun to work with as well. And please join the group, especially if you are in the New York, New Jersey area. This is a really awesome group to join and learn from. And yeah, my name is Ray. I'm a developer advocate at Google Cloud. And what I do is to bring some of the best technology from Google and from open source to developers all over the world. One of the projects I personally work on and started about 2 years ago is something called Spring Cloud GCP. So if you are using Spring Boot, which I think every Java developers are using today, and you want to try Google Cloud, check out the project. It's really awesome. And if you have any questions, you can find me on Twitter, which is Satanism. And finally, all of the content that I talk about, all of the information, you're going to be able to find it on my website, which is satanism.me. Like what Rodrigo said earlier, I love to take photos, and that is the DSLR that I used to have, which I lost on the way to a Java user group, actually, unfortunately. And I finally got a new one just recently. And on the way, on this photo, though, it's pretty special to me. Basically, I was traveling. I was backpacking in Asia for about 4 months, and I came across this city in China where they didn't really have a cheap place for foreigners to stay. And so as a backpacker, I couldn't justify spending hundreds of dollars a night staying in the city. And so I asked around, and 2 people actually told me independently from each other that if you take a bus to this other place outside the city, like 2 hours out, and if you transfer to a car and have the car drive you to the entrance of the desert, then you can walk 4 hours into the desert in southwest direction. And after 4 hours, you're going to find a real oasis, and you can stay there for free. And I heard the word free, and I asked, which bus do I take? Now, I don't know how many people here actually hiked in the desert before. It's actually really hard. It's really difficult. It's not like walking on the beach because the sand is really soft in the desert. And when somebody tells you to walk in the desert for 4 hours in one direction, then you go over these sand dunes with the soft sand, so your foot sink a little bit, and you have to pull yourself out. And it was hot, it was dry, I had water, I had a heavy pack, and it was treacherous, it was hard. And the whole time I was thinking, I thought I'm on vacation here, but I felt like I was writing a J2EE application at work. Okay? But the end was really, really beautiful. I don't have the beautiful photo here, but the end was actually beautiful. And I think that's what we all want to get to, which is to go to production. But the road to production, the journey to production is not always easy. And I hope that today I can show you some of the tips and tricks I learned about containers so that in your own journey, you don't have to go to the desert yourself. Maybe I can help you and helicopter drop you somewhere along the way, right? So I'm going to just talk a little bit about containers. There's some structural issue that we have to talk about and why containers is important. And we're going to dive straight into some of the tips and tricks that I learned myself, okay? So suppose you have like now we all talk about microservices, right? So suppose you have a system that's composed of multiple services. Like in this case, we have the front end and 2 backends and some like database and Redis that we have to connect to. Right, in the old days, what we do is that from my machine, like this particular machine, this laptop, I'm going to install Java. I'm going to install Node or Python because these services are written in some other languages. I'm going to install MySQL. I'm going to install Redis all on my machine, right? And then I'm going to try to start all of them together in one shot. And assuming that everything started, then I can then test my application. And then when we go into production environments, right, we have to do the same thing again. Usually somebody would have to say in the document, in this environment, we need to install, the JVM, we need to install this version of Node, we need to install Tomcat, we need to install this and install that. And then we need to install MySQL this way. And then finally, somebody would follow this documentation in QA, in staging, in prod, and reinstall all of the same components over and over and over again. And this is usually where these issues come up, where we say, well, it works on my machine, but not in production, right? Because the installation itself might actually have issues because it's a fully manual process. And for Java developers specifically, we also used to package our applications into YAR files or WAR files, and then now we need to deploy them into Tomcat or WebLogic or something else, and all of these things have to be configured as well. And this is why we treat the machine almost like a pet, right? Because we spend so much time and effort to configure this machine to do exactly one thing, which is to run my application and my application only. Okay? And we do this to not just one machine, but we do this to many, many machines. And if you're lucky, you get to set up these machines automatically. If you're unlucky, you have to do this by hand for all of them, right? So this is where a container, again, is really, really awesome because we can actually package up everything that we need for my particular application, not only with the application code, but also the actual application server, the actual Java runtime that I need, and with any of the tooling that I actually need for this particular application to run. And we can package all of these things up into a single container image. And this container image will then be stored in an immutable way. And then we can then push these container images out to the machines that actually want to run them. So now if you think about it, the machines don't actually have to be configured. The machines just need to know how to run and start a container image. And now as a developer, we have almost full control into what this container image should look like and also what should be configured in this image. Okay, but with control, we also have a lot more responsibility now as well, because we have direct influence in what is going to be running on the production environment. Okay, so a few concepts that we're going to go through is Docker layers and why they're important, and then how do I actually write one up. Okay, so typically you would have Docker installed, right? So in this case, if I go back to my machine, this is my machine, I have Docker installed, right? I can say Docker PS, and this is where I can see the running containers. I can do Docker images to see all the container images I already have. But let's assume that I have nothing. Then what do I do? Right? I'm in this environment where I have my own Java source code, so I can do Maven package. This is on my machine, right? I can run this test. This is just a simple Spring Boot application that will listen on port. And usually we have this file, which is the jar file, or if you're using war files, then you have the war file, and then now you have to install Tomcat and everything else to run this. Okay. Now the easiest way for anyone to kind of get started to understand Docker itself is to create a Docker file. Okay, and this Docker file has the thing that will has all the instructions on how to actually create this container image that has the runtime environment. In my case, I need a JVM, and also the application itself, so that then we can push this container image to everywhere else, right? So if you really think about it, for Java developers, we always have the dream of write once and run anywhere. Well, that didn't really become a reality because in order to run everywhere, everywhere would have to have the same environment. And now with container images, you can think about this as a packaging format that packages not just your code, but also the runtime environment as well. And now you can take this environment and run everywhere for real. Okay. So I'm going to start off with the Docker file, and I'm going to show some of the common mistakes that people make and some tips here. And then I'm going to show you some other tools that can ease this entire process so you can forget everything I just said in the next 15 minutes. So, all right, but it's important to understand because a lot of people still write Docker file, and every time I see a Docker file, I cringe a little bit because it's so easy to make mistakes. Okay, so I'm going to start off with something really simple, and this is what usually people do. There's we do a from maybe Ubuntu or some base image, and then we can run command lines like I need to install the JDK, so we do apt-get update, and then we do apt-get install. Because this is going to be a non-interactive environment, there's no way for you to answer any questions. So usually in Linux, when you do apt-get install, you get prompted like, hey, do you want to install this? Are you sure? In this case, because it's non-interactive, so you have to make sure we just say yes to everything, or you give it the configuration that you want. And then I think that the package we can install is OpenJDK, something like that, right? And this will install everything. And then once we have Java, we can copy. So we can copy file from my local machine here. So I'm going to copy from my target. We have the jar file. So I'm going to just be easy here to start jar. I'm going to copy it to a single jar. And then finally, we can now have Java. So we can have the entry point, which is the command line we want to run to start this container. Okay. And in my case, I'm going to say java-jar and app.jar. And that's pretty much it, right? So as you can see with the Docker file, what we can do is to say, let's start from somewhere, start from something basic, and then I want to customize this environment so I can run command lines. So here we have a lot of run commands, right? apt-get update, apt-get install, as if you would do in a real VM. And then you can copy file in, and then you tell it how to start, okay? And then once you're done with this, if it builds, then ship it, okay? No, actually we don't, right? Because there are so many things wrong with this particular Docker file, and we're going to break this down in a second. But let me just make sure this actually runs, right? So, for example, if I were really trying to do this and make sure everything works, I can go ahead and say Docker build -t, so I can give it a name of the container image. So every image will have a name, and then we're going to build from this context directory that has the Docker file. So if I do it this way, you can see we're actually sending this Docker file to the Docker daemon, and the daemon is going to interpret this file, and then it's going to run through the command line one by one. So we can see that the first command it went through was apt-get update, and the second command line it went through was apt-get install, right? So it's actually doing this thing in the container image right now. And then finally, it's going to copy the file into the directory and then compile this entire container image once this is all done, okay? Now, what is wrong with this file right now? Well, there's many things wrong. And I'm going to show this once this actually finishes, okay? And as you can see, this process is actually really slow. There we go. So we're almost there, right? So we went to update, we went to install, we copied the jar, and out comes the container image. Yay! And then, of course, this runs, right? So we can say Docker run, and give it the container image name. This is in my own daemon, and of course it starts, and we're happy. This is exactly what I wanted. We ship it to production. Let's examine what is wrong with this. Well, first of all, if I go back to the from line, what Ubuntu version is this, right? Because if we don't specify anything, then it's going to be using the latest version. Well, what is the latest version? Well, in Docker, there is the concept of the images and image layers, okay? So in this case, this particular image, Ubuntu latest, points to a specific version that is actually on Docker Hub. Okay, so these images are now on Docker Hub right now. And this latest tag will resolve into a SHA hash that's actually the container image we're trying to use. What then happened is that today I'm using Ubuntu latest. And then I do the build again tomorrow. The latest version of Ubuntu may have changed, but if I do the build again, because my Ubuntu latest was already cached on my machine yesterday, what's going to happen is that it's going to keep on using the older version of my base image here without actually updating to the newest version. And there's no way for you to know what that newest version is unless if you explicitly pull down this latest version again, right? So for example, if you do Docker pull Ubuntu latest, if you pull it today, it's one version. If you pull it tomorrow, it could be different. But if you don't do it this way, you could always be building against the old version of Ubuntu. So one thing to guard against it is actually never use the tag latest. Always know which version you are trying to use. The second part of it is that when you do the build, there's if you have the time on CI/CD server to do the build, for the long, taking a little bit more time, there's a little thing here called no cache, which then will make sure that when you're building it, you're not actually pulling from any cache that's already on the machine. You'll try to get everything anew again. Okay, so just be very careful with this. So number one, never use latest as your base image. Number two is that if you do run some of these command lines to customize your environment, you have to know that everything you do here becomes a layer. So every single one of these lines becomes a layer, and the amount of data that this particular command line uses or creates is going to accumulate to the next layer. Okay, and then it's going to accumulate to the next one. So what that means is that whatever you do in this layer, in this command line, if this generated 100 megabytes in the output that got stored in the file system, you will be there forever, even if you do something like rf var cache apt archives. So this is the one way to get rid of the downloaded data. So for example, apt get update will download data, right? Download the Debian packages. And then if you try to delete it later, well, it's not going to get deleted because this layer still has the data. If you do rm here, it's not going to have any effects at all, right? But when you run this container, you will not see these archive, but in the container image layers, the amount of data is still there. Okay. So for example, if I come back here, one easy way to see what's in, which layers are being created, let's go to use the Docker history command line. I can say, let me see the history of the container image I just created. So we can see the history here. The first couple of things, these are the ones that's coming from the base layer from Ubuntu, right? And then you can see the command line here, which I did apt get update. And that downloaded 28 megabytes of the Debian packages, or of the cache itself. And then I did the run here, which is apt get install, and that downloaded 390 megabytes of data also. And finally, I copied the jar file over, and that's another 30 megabytes. So this entire container image as a whole is about 450 megabytes, right? Or even 500 megabytes. That is really, really big for a single application, a single microservice, okay? So just be careful with this. What can you do differently is that if we know that this layer, every command line generates a layer, then what you can do is to minimize the layer that's being created. So in this case, what I would really want to do is to run all the command lines in one shot. So for example, I can do something like, let me do the apt get, do the apt get install, and then remove anything that I do not need, right? Because in the apt install, it actually downloads the archive and then installs it. So you're actually using twice the amount of disk space that you need. So if you're doing one shot like this, then you're going to save a lot of space because you get rid of what you don't need in the end, and now you're only left with the JDK. A few other things is that if you do actually do this route, you can do what we call just don't install anything that you don't need. So in apt, for example, you can do no install recommends. So what this will do is just don't install what they recommend you that you should have. If you don't need them, why install them? So just don't install recommended packages. And finally, one thing that a lot of people make is actually to create this runtime image with the entire JDK. Do you actually need the whole JDK to run your application? In most applications, if you don't need to do any compilations additionally to what you already have, you can just run it with the GRE instead. And that's going to save you a lot more space as well. So now if I were to rebuild this container image, if I go through this environment, this build again, what we're going to see is that the output of this is going to be a much, much smaller image. Why? Because we're not keeping the Debian packages around because they're already installed. We're installing just the JDK, so just the GRE instead of the entire JDK. And we're also installing only the packages that we need, but not the extra ones that's being recommended. Okay, so we're going to hopefully very quickly to see the differences between these two container images. Okay. Very, very important stuff. I have seen many mistakes in terms of trying to create a container image, and people end up with gigabytes of container image or 2 gigabytes if you're not careful. This can really happen. Okay. So now this build is done, I think. And now if I do another history, what we're going to see is now we have slimmed this down a little bit. So the container, even after deleting some of the data, I think I didn't delete the right data. That's why I still see 366 megabytes here. But overall, it's a little bit smaller because we don't have the apt-get data because we remove all of that too. Okay. Now, the other mistake that a lot of people make is that, well, let's ship it, but the problem is which container user is this actually going to be using? Okay, so this is about the run user, like which user is actually running this application. Now, one thing that people forget is that containers are not security boundaries. It is not a VM. A container that's running is not a VM. What that means is that potentially some people with privilege might actually be able to hack around the containers and be able to get out of it and to compromise the host, right? That's a possibility. You want to minimize that risk. You want to minimize that possibility. If the user here running this process is running as root, then the possibility is greater than if you're running as a nobody. Okay, so by default, most of these container images that you get is going to be running as root. So that is a bad practice. Do not run as root. Okay, and one of the easiest way to not run as root is just to make sure that you don't. And in the Docker file, you can specify the user directive here. I'm going to say, let me run as user nobody and no group. Okay, and now we can be pretty sure that we're not running as root. The other thing that you may want to consider here is that these files that's copied in, when you do the copy, it is still copying the file as root as well. And there may be good and bad about these. If it's jar file, maybe it doesn't really matter. But sometimes if you are copying, like say JBoss or Tomcat, you want them to run as nobody as well, because you actually need to write some files when they unpack the war. You actually need to write to those directories. In which case, what sometimes people do is to do run, and then you run chown, right? Change owner, and you say, let me run chown nobody, no group to app.jar. However, what this will do is to actually potentially create another layer that has exactly the same file. So now you duplicated the amount of space. And in this new copy of the file, they changed the ownership. Okay. What happened then is, remember, even though when we're running it, the ownership has changed. But if you look at Docker history, you're going to see it uses twice amount of the disk space, right? It's going to copy the jar again and then modify the ownership. So luckily, in the newer versions of Docker, you can actually use the chown. So we can say chown to nobody and no group, right? So this way, during the copy phase, it will actually make sure that the right permission is being set. And then in the run phase, you will actually run it as nobody and no group because of this user directive. Okay. So just a couple of things to be very careful with. Right? The final thing is, well, if I'm installing Java here, why don't I just use an existing Java base image? And I think that's what people should do. Always find some officially supported base image that you can use so that they take care of most of these issues for you. But most of these images are still going to be using the root user, and you want to still make this adjustment to make sure that the user is not root. So for example, what I can do here is to, rather than doing the Java install myself, I can go ahead and just use OpenJDK. And also remember, try not to use the latest version of anything. So you need to be specific. So let me see which OpenJDK versions we can actually use. So here we have, I'm going to use the older version for now, and I'll show you some of other issues. Okay, so I'm going to use the older version of OpenJDK in this case, right? And then I change the ownership to user to nobody, and then I copy the file as nobody as well, and then I start my application. And now I can do another Docker build, right? Now, sometimes what people do here is that, we will try to copy in the source code, and we want to build the application in the container too. Now, why would you actually want to do that? Well, one thing is that if you actually want to have a reproducible build, then maybe you need to control this build environment very carefully. So imagine now we are packaging up our runtime with our runtime code. You can think about it, you can package up the build environment with the build code, right? So then what people then do is potentially to, from this container image, we copy in all the source. So I'm going to copy everything into source. And then I'm going to run Maven package or test or verify. I'm going to say run verify. And I'm using a Maven wrapper here, so I can do some cd into source and run Maven verify, right? And then now I can copy directly from the target directory, like this, target directory, into app.jar, and then I still run it. I have seen this done over and over again in some potentially questionable Docker file, and this is applicable to both Node applications, Go applications, anything that requires compilation. This is really, really bad, potentially, because now your container image is going to end up not just with the runtime environment, it's also going to end up with all of your source code and also anything that Maven downloads. So the entire Maven, like the plugins and all the dependencies, that will all end up in your container. Okay. And your container would not just be 500 megabytes large now, it will actually potentially be a gigabyte or more, right? Because you're downloading all these build time dependencies. So in Docker, another neat trick here is to use multi-stage build so that you can do the build in one stage. And then in the second stage, you can copy the file that you want to the runtime container. So the way to do it is by using multi-stage build. For example, I can mark this first build, the first section of this as the build image. And then I'm going to copy this over. And the final image is, I can call this as run image, right? So now we separated these two different tasks. And then in the run image, what I'm going to do is to copy the file from the build image, right? So now, rather than having a giant container image that has the source code and everything else, I delegated it to the first container image here, which is not really being stored anywhere. And then in the final output, I'm going to have, again, a much, much smaller container image. Okay, so I'm going to try this out. I'm going to say Docker run. Sorry, not Docker run. Stop. I'm going to say Docker build. I think I may have named the image name a little bit incorrectly. Let me see here. OpenJDK. Oh, yeah, that doesn't exist. Well, that's too bad. OpenJDK 252. Sorry, 252. There we go. 252. 252. Yeah. So let's build this, and that should do it. Okay. And now my container image will do the build so that the build is reproducible because the build environment is exactly the same. And then I can also produce a small container image that I can use. Okay. So let me go back to my slide a little bit to make sure I don't miss anything. So I'm gonna come here, right? We we do the build. Remember, every command line that you run is going to go into a container layer. Okay, so you want to reduce that. And then we combine the run commands, right? So we, rather than doing fd-get and then install and then rm, we do everything in one shot, and this will produce a single layer that has minimal space. Don't install, the JDK unless if you need to. Use the GRE. And sometimes it's much easier if you just do the pipe without any unpacking. So like in this case, if I'm to download Tomcat, which is a tar.gz file, I can avoid saving it and then unpack it. I can just do tar.xz from the pipe directly. Okay. And finally, please do not write anything to the container file system, right? Because whatever you put into the file system in the container images might actually go away in the next run, because the next time you start your container, you will start off fresh, and then you're actually going to lose all the data, right? So don't write anything to the container file system unless it's something you actually need and it's actually ephemeral. Now, one thing I'm going to show here is that what happened here? Oh yeah. So in the JDK, in the build image, I'm going to use the JDK, and in the runtime image, I'm going to use the GRE, right? Because the GRE cannot compile, so that's why this actually failed. Okay, so I'm going to run this again. Now, the other thing I'm going to show is that, remember we did Docker run, so every time we do this, this is one of the most common mistakes that people make, is that we do Docker run in my container image, right? Nope, Docker. And why is this downloading again? Hold on a second. Sorry. I'll get into this in a second. So I'm going to do Docker run again, my container image. It's 7 o'clock here, which is great. We're appreciating all the emergency workers here and the people who are on the front line. So if you're hearing some honking and noise, that's actually people outside celebrating at 7 o'clock here in New York, or technically I'm in Hoboken. Okay, so I'm going to continue here. Usually what people do is to do Docker run, right? Docker run, Docker run, Docker run. Every time you do this, we're going to do a Docker run. In about 2 weeks' time, you're going to find out that you are running out of space. Okay. Now, why is that? Why are we running out of space in some of these Docker runs? Well, when we exit out of the container like this, right? What happened then is the entire file system that you actually created, they're actually going to keep it somewhere. And this is still being kept around. In fact, one easy way to see what you're running in Docker is to Docker PS, right? But if you want to see what else is still there that hasn't been deleted, you do Docker PS-A. And what this will do is to show you, wait a second, all of these other things I ran previously are still there, okay? And all of these things are going to use up potentially disk space. And if you do this over and over again, if you do Docker run all the time, then you're going to keep all of these containers around without you even knowing it, okay? And so what you need to do then is to actually remove it manually. So you say Docker IAM, and you can get rid of this container that was previously running, but now it's stopped. But one unique trick here is that you can actually start this container again. So if you ran something 8 seconds ago, you stopped it, and now you want to restart it again, you can say Docker start, and we'll start the container again as is, as if you are taking a snapshot in time and then we're restarting it again. But if you want to stop it, you can say Docker stop, right? Now then what happened is that these container images will be around. So one neat trick here is that everyone should be doing this, which is that when you're doing Docker run, always use --rm, so that will actually delete the container instance for you afterwards. Okay, so rather than having to Docker rm yourself, this will rm the container instance for you automatically behind the scenes, right? So if I want to stop again, this will not show up in Docker PS anymore. The other thing is that for Docker PS with -a, you may really just want to go through it and then get rid of everything, right? So I'm going to say rm, this one, and there's a little script in my slide that will help you do this. Do that and do that, right? And it will get rid of it. However, the container image might still be there, like the disk space might still be used. So what you need to do, what you can also do is to do a Docker system prune. And this will get rid of everything that's dangling, anything that's in the cache, anything that you don't want, all the stop containers that you don't need anymore. You can run the prune, and as you can see, there are already some images I'm pruning. And just like that, I saved 2.5 gigabytes of disk. Okay, so run the system prune periodically if you can. You will be amazed how much disk space you're going to be able to save. Okay. And here are some scripts that you can do, right? Docker ps-a-q, but easiest thing, just use Docker system prune. Spotify also has a little utility called Docker GC that will help you garbage collect, so you can run the script periodically and get rid of the things that you don't want as well. Okay. And finally, always run with Docker --rm. Okay. And we talk about pinning your versions. In the base image, always pin your version. Don't run as root. We'll talk about that. And sometimes you do want to know what's in the container, right? Like, for example, if I were to tell you, hey, go ahead and run Docker Satanism slash, I don't know, demo. Like, do you actually want to do it? Especially if I ask you to, find the volume, like root to root, right? You probably don't want to do that, right? Because you don't know what's in these container images, okay? Same thing if you use any container images as a base image, you don't know what's inside. So it's really, really important, especially for large enterprises, to understand what is in that base image. And more importantly, what is in this entire runtime that you just built. And so another tool that you might need to look into eventually is how do you actually scan vulnerabilities. There are two tools out there that I know of. If you're using Artifactory, X-Ray is one really good example of this, which can help you to scan what's inside of your container image. And on Google Cloud, we have container analysis. So if you store the container image on Google Cloud, we'll also analyze what is in the container image, and we'll give you a vulnerability report as well. So that's really, really cool. So always know what's in your container image. Now for Java specifically, if you want to do this Dockerfile build, there are some Maven plugins you can use. My favorite right now is the Dockerfile Maven plugin. If you want to do it with Dockerfile. But, my friend Matt Rabel, who works at a company called Okta, he famously says, friends don't let friends write authentication. Every time you start a new project, the first question is username and password, where do we store it, and how do we authenticate? You don't have to write that if you use a single sign-on service, right? And it's error-prone. You can make a lot of mistakes. It's repetitive. I'm going to say, friends don't let friends write Docker files, right? So forget about Docker files. Forget everything I just said, right? For Java applications, you can just jib it. What does that mean? Is that you can use a container. You can use a Maven plugin. Sorry, here. Where's the Maven plugin? Right here. Okay. So rather than writing the Docker file, which I need to follow to implement some of the best practices, with jib, I don't have to write the Docker file at all. And jib will actually automatically analyze your build and automatically separate your application into multiple layers. So you don't have to do it yourself, okay? And then it will also automatically be able to push this container image into a remote registry, which is super nice. And you can do all of these things even without a Docker daemon running on your computer, or you don't even need a Docker file at all, right? So all of these things I just done, if I were to just delete it, I'm going to delete it right now. So it's gone. I can still build a container by using jib, by saying maven compile and jib build. And this will create my container image and push it to the registry, just like that. And this is one of the easiest way to build a container image for Java applications, right? Don't write the Docker file unless if you absolutely have to, okay? Now, finally, for these container images, you may actually want to tag it somehow. Remember I said do not run a container image that's running as latest. Same thing as your container that you're trying to build. So one way that you can do this is to automatically tag your container images, potentially with like the git commit or with a build number. So you should always do that. Especially in Java, there's a really neat plugin out there called git commit ID plugin. So you can run this plugin, and then you can reuse the variable that it generates, and will automatically push the container image with the right tag. And now when you're trying to deploy it, you can use the tag as well. Okay. So for example, if I come back here, I created a new container image here that's pushed to my registry on Google Cloud. That's being vulnerability scanned as well. And I also pushed out the container image with a specific tag, also based on the plugin. Okay. Now, finally, for Java developers, one thing you have to watch out for is the JDK version. In container, the JDK version matters. If you're running anything older than OpenJDK 142 or Java 8, 8U142, some people still run Java 7 or 6. Forget about containers. It's not going to work well for you, because what's going to happen is that the JTK, the JVM, will actually see the amount of memory it can use, right? It's trying to configure the max heap based on the size of the memory that you have on the machine, unless if you explicitly set it, right? So if you're using the older version of the JDK, if you're running your application this way, so in this case, I'm going to do a Docker run. I'm going to limit my container to one CPU only, and only 256 megabytes of the memory that you can use. If you exceed it, Docker will kill the container. Okay, this is where you see what we call OOM killed, out of memory killed. It's no longer out of memory exception. We're now talking about OOM killed from Docker. And the reason this happened is because you exceeded the memory that you can actually use. And I'm going to run this through the older version of the JDK, which is under 142. So this is AU141. I'm going to print out the max heap. And the older version of the JDK does not understand this constraint that we have put around the container. So what this old version of the JDK is going to see is all of the memory that's running in my machine. Okay. And I have like 16 gigabytes of memory on my machine. And so the max heap is actually going to be calculated from that. So what is this size right here? This is in bytes. I'm going to use my favorite calculator, which is Perl. I don't know if anyone still use it. I'm going to use Perl. I'm going to print out this bunch of bytes, divide by K, and divide by megabytes. I'm going to go all the way to gigabytes right here. So this heap size is actually 25 gigabytes. And that's because my machine is actually 32 gigabytes large, and the JDK think that it can use 25 gigabytes for my max heap. And this will not garbage collect until you are under pressure, and you're going to exceed this memory limit like in no time, and your application is going to die. If you use the newer version of the JDK, everyone should be checking. You should always know what JDK version you have. If you're using the older, newer version of the JDK, let me see here, 252, I think, then this value will be correct. If I constrain the memory size to 256, you can see that this max heap size is automatically adjusted to a smaller size. So if I print this out, 124, and we're only using about 126 megabytes for the heap. Okay. A lot of people do get OOM killed. So one last note here is that there are a couple of tools that can help you to estimate how much memory you actually need to use. For example, there's Cloud Foundry Java Buildpack Memory Calculator. The function of the memory usages is actually potentially the same as the amount of classes that you have in addition to the heap. So they can actually give you a really good breakdown on what type of memory configuration you should use. And finally, if you're really, really in trouble, if you really need to know how much memory is actually being used, because in the JVM, you use not just the heap, but also the native memory that the JVM uses, you can turn on what the newer version has this feature called native memory tracking. So turn this on. Upon successful exit, it's going to tell you the breakdown of native memory usages plus the heap usage. And this will help you understand exactly how much total memory you are supposed to be allocating for your application. Okay. Now, finally, for testing purposes, there's this really, really neat utility called test container. It's a really good Java library. It also supports other languages too. What this allows you to do is to avoid having to spin up containers or set up MySQL on my machine locally before I run my tests. What test container can do is that in the unit testing phases, I don't have it here, but during the unit testing, we can add a annotation called test containers, for example, and then you can just use something called container annotation here to tie it into your unit testing cycle, and then you can create something like a post. I don't have it here right now, but you can add something like Postgres SQL container, and you can say this is a new container, and then you can give it SQL container image, for example. And then you can say, I want to start PostgreSQL 8 on my machine. And if you do it this way, every time the unit test starts, the new container image will be created, and then you can bootstrap it with the test data, so you don't have to keep a Postgres or MySQL database running the whole time. This will just be tied into unit tests, which is super awesome. I'm working on a project right now, just over the weekend and right now, actually. And we are using test container everywhere to bootstrap MQ and bootstrap the database and emulators and everything else. This is super, super cool. If you are playing with containers or if you're developing against containers, definitely check out this project. Okay. Finally, more things is like, please do not put secrets or configuration in your container image. This is again why I don't want people to write Docker files, because it's very, very easy to, I have seen this in production environments from like many different companies where when they do the Docker build in the Docker file, they say copy my configuration file or my secret file into my container image. Now this file, this secret, will then be part of your container image, which you're going to push into a registry provider, which may or may not be encrypting this container image at all. You don't know this, right? At Google, we encrypt everything at rest, but in other registries, you don't know, and you do not want any of your secrets in these container images. You want to externalize them a little bit. Okay, I'm gonna move on to this other thing I really want to talk about, which is right here. Okay, so I do live in the New York area. Actually, I'm technically in Hoboken. So when people hear this, I'm like, oh, you're not really from New York. It's fine. Point taken. When I first moved to New York, I also live in Jersey City. Again, it's not New York, it's still in Jersey. So in Jersey City, I was trying to find a place to stay, okay? And I found this place on Craigslist. And on Craigslist, the advertisement looked absolutely beautiful. It's a really, really beautiful place on Craigslist. Then I went to check it out. What I realized is that it's only about 18 square meters or 180 square foot, okay? And this is the layout of this apartment. And because I work at Google, I thought, hey, I don't need a kitchen. I can just eat at the office. And so I decided to sign on to this place. It's small enough for me. It's big enough for one person, right? And also that Wi-Fi is free. Because the Wi-Fi is free, I decided to take this place. And this is the layout of the place. As you can see, this place is just as big as a bed, right? This is the box here in red. That's the size of my bed. So I have a sofa bed, which I can open up. And the first thing I did was to get a 50-inch TV. And the TV is on the wall on the top here, right here on the top. And surprisingly, the TV just spans across the entire wall, which is fantastic. And everything I brought from California, where I moved from, to New York, I was able to fit into the closet. Now, one last thing is that the space on the top right-hand side, that's where the restroom is. That's the restroom, which is really big. It's a full-size restroom, a bathroom with the tub and everything. Unfortunately, one thing is that the landlord told me there was free Wi-Fi. There was, but the Wi-Fi access point is in his unit, which is above me. And Wi-Fi signal does not travel vertically; it only travels horizontally, apparently. And for me to actually get a signal, I have to sit next to the restroom. Okay, so eventually, what I learned to do is to not work in my room anymore. So I travel a lot. I go to Starbucks. I'm on the airplane. I'm on train a lot, right? So what I actually learned to do is to live with Docker on a really, really slow Wi-Fi. Okay. So I'm going to show you some extra things here. So yeah, there's a door, there's a closet, there's my mini fridge, there's the bathroom, and 50-inch TV and my sofa bed. Okay, and the Wi-Fi is free but slow by the bathroom. Okay, so so I learned to work with really, really bad Wi-Fi. Okay, and just for comparison, so you know how small this place is, and we're talking about containers, right? These are standard size containers: 20 feet, 40 feet, 45, 48. In my room, it's about this size. That's the size of my apartment. So you can say that I live in a container for a good 2 years before I move out of it. Okay, so how do I actually live with this really, really slow Wi-Fi? If I'm traveling all the time, I'm if you ever try to, a lot of people do this, they pull down Ubuntu on their machine, Docker pull Ubuntu, right? And it's like 500 megabytes large. And if you're doing this over slow Wi-Fi, forget about it. So what I actually do is I run something called Docker machine. A lot of people do not realize this, but Docker is really just a daemon, okay? And whenever you do Docker build, it's actually sending some files to this daemon, and the daemon process will then process what you're trying to build and create the container image. This is really, really important to remember. Docker is a daemon, okay? And whatever you do is sent over the network or over a socket to that daemon. So there are a couple of things you can do. First of all, I can run the Docker daemon elsewhere. It doesn't actually have to run on my machine. Okay, so if you think about this, then what I do is I run my Docker daemon in the cloud. Okay, so now if I'm right now actually whenever I'm doing Docker build, this is actually sending the instruction to my Docker daemon that's running in the cloud in Google Cloud right now, and my cloud is actually doing the build for me. And think about it, this opens up a whole lot of opportunities and possibilities. Okay. Now the second thing is that what you may have seen is that earlier, I deleted the Docker file. I need to get that back. So I'm going to copy a Docker file back here. Docker file 1 to Docker file here. Okay. Now I'm going to do the build again. So now, if I'm doing the build, you can see that we're transferring the context. Okay. The transfer context here, this is actually sending my source directory into the Docker daemon. On your own machine, this could be very fast, but because I'm working on this over the internet, the sending of the context might actually take a long time because it's actually going over my Wi-Fi. Okay. Now, if I'm working in Starbucks or somewhere else, this might take forever. Now, why is it sending such a big context? Well, it is because what Docker will do by default is to send this entire directory, the context directory, which is the dot here, to that daemon over the socket. And a lot of the times people do not realize it, but you can actually restrict what you want to send over to the daemon by configuring the Docker ignore file. Okay, so in this case, I'm going to say, you know what? I'm not going to send anything that's already compiled, so I'm going to ignore the target. And if I were to do this build again, Docker daemon will only get the source code rather than the source code plus my other artifacts, which they don't really need at all. Okay, so in this case, I just reduce what I send to the daemon by multiple folds because I only sent in about a couple kilobytes for my source code. Okay. The other thing is that to further expand on this daemon concept, this is why also there's a compressed flag. This is that Docker can actually send the data compressed. So now my source code that I want to send into my Docker daemon is fully compressed. Okay. So that they can unpack. So now I use even less bandwidth to compile my code. Okay. And then because I'm using multi-stage build, now I can send in a very small source code compressed over my network into my Docker daemon, and my Docker daemon will do the heavy lifting of downloading the Maven repositories, downloading any dependencies, and then compile everything for me and produce this final output, which could be 200 megabytes large. And then I can push from Cloud daemon to the Docker registry. In all of these processes, I never have to use my own bandwidth. And this is how I deal with most of my demos. This is how I deal with this is just what I do normally. Everything I do is running on Docker daemon remotely. Okay. And because sometimes people ask, Ray, how did you actually do that demo over a cell phone connection? Well, that's because I run my Docker daemon remotely. I never once needed to actually use the full bandwidth that's available on my cell phone. Okay. A few other final tricks is that one thing that people do not realize is that Docker, when you're running this locally, it's really connecting to the daemon, but you can actually do the standard in and standard out as well. Okay, what that means is that you can run a job, and that the job can produce some output, and you can pipe the output out, right? So like you can say Docker run a job, and then you can pipe the output out, and you can pipe it to a file if you want to, right? What people do not realize is you can also pipe the file in. You can also receive std in as in addition to std out. Okay, so once you understand this, then you can do very, very special thing, right? You can pipe inputs in and you can pipe inputs out. Okay, so for example, one last thing I'm going to show is I have this container. Let's see if I can find it. This is the last thing I want to show. If I go to project, git devrel, I think I have a deep learning container here. So I have this little container that helps me to use deep learning to enhance an image. Right, this is called Deep Dream. This came out many years ago, where they are able to see what the neural network has actually learned in a way. So you can feed it a image, and then you can tell it to iterate on what it sees, and then eventually it becomes this new image that's actually went through neural network, and the output is really stunning because you're really looking into what the neural network is really seeing in a way, and you can see what they're seeing, and it feels like you're seeing a dream. Okay, so I have this little container called Deep Dream CLI. Okay, so let me see the README here. Okay, so I can run this container like this. I can run the container, Docker run. I'm going to run this using what I already done. Okay, so as you can see, we're downloading this container image right now, and this is actually downloading from the cloud. Okay, because I'm doing cloud to cloud right now, so this is great. So I'm actually not downloading this to my own machine. This is really just going to the cloud. Well, actually, just to make sure, let me just make sure I am actually going to the cloud, and let's try this again. Yeah, this is definitely going to cloud. Okay. Now, what we can do, the last thing I'm going to do is just to show you how to pipe things in. Okay. So I'm going to feed a picture of a cat into here. So this is one of my favorite photos as well. Let me go to downloads. No, I think it's pictures. Pictures. Open the dog picture. So this is the dog profile picture that you saw earlier. Okay. And then I'm going to open the cat picture as well. This is a little cat. I think I took this photo in Tibet a long time ago. Okay, so what I'm going to do is to feed this cat into Deep Dream, and we're going to see the output as well. I'm going to do this all through the container too. So what I can do, I'm going to again see the README. What I'm going to do is I'm going to cat the cat. Get it? We're going to cat the cat. I'm gonna do the pipe so everything comes out to std out, and then we're going to feed it into my container, right? So I'm going to do the Satanism/Deep Dream CLI, and then in the CLI I can also do some command line arguments. So I'm going to code the CLI that's going to be started from the container, but also with the arguments just like it's a regular command line, right? And then I'm going to put the output into it's going to output the final image via std out, and we're going to pipe it out. Okay, so you can cat a cat into the container. It's going to read it and then pipe out the result into std out, and then I can pipe it into my file. And if I open this up, this is the cat image that's being deep dreamed, right? So you can see the patterns that's actually forming, and you can actually run this multiple times. Eventually you're going to see something really trippy, and that is going to be pretty cool, but that will take a little time to run. Okay, so let me just go back to my slide and make sure I got everything here. Finally, yeah, the last thing I want to say is that if you are going to run the container somewhere, I've seen this over and over again. You go to the VM and you say Docker run, okay, and then you leave it. That is not the way to start a container anymore nowadays. What is really nice is to be able to orchestrate the container deployments across the entire cluster of machines. And for this, I highly recommend people to look into Kubernetes. If you haven't done so already, please try it out. On Google Cloud, we have something called GKE. So you can start a Kubernetes cluster. You can have an entire cluster, right, with multiple machines. And now you can use it to orchestrate. By that, I mean being able to deploy container images across multiple machines and starting them all at the same time. And it's one of the easiest and best way to run your microservices today. So if you are interested in that, please check it out. With all that, I think my time is pretty much up. I want to thank everyone for being here and listening in on YouTube Live. And if you have any questions, please ask in the chat. Otherwise, Rodrigo's and Jing, I think I'm pretty much done.
So
If you
I
have
have
any thoughts, you can go to my site for more info. Okay, yeah, go for it.
I have 3 questions that I've been collecting, and for everyone listening to this, remember to type more questions into the chat. The first one is probably not about Docker. Someone wants to know what the story is behind your Twitter handle, Saturnism.
That's funny. Yeah, I used to talk about that story too. That's a good one. So I don't know if anyone here use IRC, Internet Relay Chat. This is way before Slack, way before anything else. It's just IRC. Anyone? Have you used IRC before, Jing?
Yep.
Oh, yeah, I did.
Yeah.
Way back.
Yeah. So IRC networks, there are a couple of big ones, right? There's Undernet and EFNet. I was on the Undernet. Okay. So what happened is on IRC is that you pick a nickname, right? So you pick a nickname and you log into the server, right? Nothing's authenticated. And I like the planet Saturn, so I chose the name Saturn. I also have a channel called 9 Planets, right? Because Saturn is one of the 9 planets, right? Just really, really old days. And then, a year later, somebody else wanted to use the name Saturn. Okay, so if that person gets on first, then I cannot use the nickname anymore. If I get on first, that person couldn't use the nickname anymore, right? That's just the old IRC. So then what do? Well, you don't really talk about it. You don't ask the person to, hey, that's my name. Like, can you not use it anymore? Then what you do back then is that you DDoS them. I don't know if anyone tried this before. So you find out their IP that they used to connect to IRC, and you DDoS them, you knock them offline, and now I can take my nickname back, right? And now that person figured that out. So that person started to DDoS me, and I just got tired of it. So I changed my name to Saturnism. This comes from the planet, and also DDoSing people on IRC.
Awesome. The second question is marginally more relevant. We had a question about what editor you were using, which was answered in chat, IntelliJ. A secondary question to that is, are there any plugins you recommend for Docker in IntelliJ?
Plugins in Docker in IntelliJ.
Plugins
I know that
make
there's
using Docker easier.
Yeah. I think there's I actually never end up using it, but I think there's a Docker plugin that you can use. The other plugin that I do know that we have built, which is the Cloud Code plugin. So if I go to here, and if I go to the plugins here, this is if you want to do some kind of iterative development with containers and also with Kubernetes specifically. Then you can install this one plugin, which I'm trying to find the list of plugins here. Where are the list of plugins? How do you actually find this? Am I missing something? I thought it's all here. Plugin? Oh, plugins right here.
Yeah,
oh yeah.
Plugins there.
Yeah. There we go. So in the marketplace, there's a plugin called Cloud Code. So you can definitely install this one too. This is something that we have created to help you with, not just Docker, but also just being able to do the iterative development on Kubernetes itself. But if you just want to deal with Docker specifically, I think there are plugins here, but I never really ended up using any of the Docker plugins, to be honest. I really just been using the command line. In a way, I feel it's good to learn about the command line. This is how I learn most of these tips and tricks myself, which is by using a command line and just really understand what every command is trying to do. I actually recommend that rather than using the UI. So,
okay, I've got 3 more questions. Reminder to folks in the chat. We just got 1 question. If you have more, do ask them. The next question is, are there any advantages of using GKE over EKS since you use Google?
Well, I don't know about I don't know EKS enough, but a couple of things that I do enjoy on GKE is that, well, first of all, the master node is fully managed, and I can spin up if I want to do production work, then I can spin up a multi-regional cluster as well, or regional cluster, so that the master is automatically configured to be highly available and spanning across multiple zones. The spin up time for our VMs is really quick. I don't know EKS. Again, I do not know EKS at all, but I just want to give you the idea that on GCP, we spin up a new VM in this environment in about 15 seconds or so. right? So we don't have to wait a long time for these new VMs to get started. Just the VM itself on GCP is pretty superb. One thing that we do have is something called live migration. What that means is that imagine if you need to, if we need to update a patch on the host machine, because these are VMs. But if I need to do any work on the host machine, in other environments, you may actually have to shut down the host machine, right? And that will actually take down your VM too. On Google Cloud, we have something called live migration. What that means is that we can live migrate your VM from one host to another without a drop of packets, which is amazing. So the VM would just keep on running. The network traffic is still coming in, but it's just teleporting away from one machine to another so that we can patch our host machines. So that is pretty cool. I don't know if anyone else does that this way, but these are a few things. And also that anytime I need to update my cluster, I just go into GKE console and I say, let me upgrade to the newest version of GKE or a specific version. I just click the button and does everything for me automatically. I like that too, because then I don't have to manage anything, right? So yeah, just a few things I really enjoyed just by using GKE myself.
Great, thank you. The next question is mine. I'm not reading it on someone else's behalf.
Okay. Yeah.
When you were talking earlier about using the JRE instead of the JDK to save space, what do you recommend doing for Java 11 where there's no longer a standalone JRE distribution?
Ooh, that's interesting. If there's not, well, actually, Adobe OpenGDK, I haven't compared their container images, but in Adobe OpenGDK, I think they do have two separate distribution. Now, I don't know what they do with that, or whether they are saving space or not. Yeah, I'm not quite sure. But yeah, if I were to go to, let me see here. Do they? Actually, I'm not 100% sure anymore. If they do, then use it. If not, then I guess it would just be the same base image. Yeah.
Okay, and the last question, unless somebody else asks another question, was partially a question, partially a statement, but someone said, is it insane to pay by the hour to compile? And Lloyd immediately replied with, depends on the price. I'm curious what your take is on that statement.
Pay by the hour to compile. I don't know what that might be the place. Well, it depends, right? Like if I'm like in the enterprise situation, right? If I'm like in a company where somebody maintains the build pipeline, right? And I know that many of the build pipelines might be broken in a way, and also that there's no capacity to build anymore, and this is a real problem. And also you have to maintain that build pipeline, then absolutely, if you can offload all of that operation and availability and the space and management, then it absolutely makes sense to pay by the hour, I guess, to compile. In this case, what I mean is to compile, do the building in a service as opposed to running your own. Absolutely, yeah. In an environment where you need to iterate fast, and you don't want to have anything constraining your environments and not having to worry about space or the machine capacities, then you have to offload the work to software as a service. And there are plenty of these CI/CD pipeline services you can use that will charge you money based on how much time you use to build your application.
Awesome.
Right?
I've got one more question. Yeah. You know it's a question because there's a question mark in it. Can you stop sharing your screen so we can see you and Rodrigo and I on video for closing remarks?
Yes, absolutely. Yes.
It ended with a question mark, so you know it's a question.
Awesome. Fantastic. Awesome. Yeah. Thank you all for hosting this. I really appreciate it. This is awesome.
Yeah, great. Thank you very much for joining us today. It was a very good presentation. In the chat, we could see that we have a lot of Java champions, so a lot of experienced professionals. But for the ones that are just starting with Docker, where do you recommend? Where should they start?
Where to start learning about Docker? I think that the Docker, to be honest, the Docker, when I first started using Docker, right, I thought the Docker site was really, really good, like really good documentation. I would highly recommend, do learn the Docker file a little bit, right? Just learning about the Docker file, try things out. And especially for folks who are using potentially Windows, I think it might be a little bit more difficult because Docker only runs on Linux, right? So even if you install Docker on your Windows machine, it's actually running in a VM. And remember what I talk about, Docker is just a daemon. So it runs in a VM. So when you use Docker on the Windows machine, it's actually connecting into the Linux machine. So a lot of the times it's really understanding the Linux command lines, right? Like apt-get, who would have known, right? Or if you're using Red Hat or CentOS, it will be yum instead of apt-get. So, if you are really just getting into Linux space, learn Linux first, and then you can deal with containers. If you're an application developer who doesn't want to deal with the container images in Docker file at all, start off with Jib. Just use Jib. If you're using Java, just use Jib and build your container image, and you're going to be more than halfway there. It's probably the easiest way. And then learn about how do you run this container image, like Docker run, and just a few basic things. And then deploy this into a serverless environment like Cloud Run or a GKE. So in no time do you actually need to use Docker in that case. You think about the container image as a way to package your application, as opposed to something that you may have to learn intricate details about, right? Like a jar file. Like how many people here knows what's inside manifest.mf? Probably very few people, right? I didn't even know this until just not too many years ago, right? But I know it's a jar, and I know I can run the jar, right? I would think about the same thing about container images in general. Yeah.
All right. Perfect. Thank you very much. So I'd like to thank one more time, everyone. Please follow us on Twitter, NYJavaSIG. That's where we're most present. We're always posting our meetings. Here we have our YouTube channel. That's awesome. Thank you very much. And I hope everyone is safe. You and yours are safe, you and your family. Thank you very much. Jean, any final words?
There are many, many, many comments in the chat thanking Ray for the awesome talk. So thank you on everybody's behalf.
All right. Thank you very much one more time, Ray. Glad to see you. Have a good one.
Awesome.
Okay.
Thank you.
Thank you.
Bye.